Hey guys, this is Coach Lowe, and this is Chapter 9, Section 5, Triangles and Parallel Lines. Triangles and parallel lines. All right, so let's get started. Let's write down a couple of theorems here. So Theorem 9-6, we'll start with 9-6 and then we'll add 9-7 in a minute. If a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. All right, so let me get a triangle on here. So if there's a line that separates the triangle, and when it separates, so it goes from one side to another, separating the triangle into, do you see the four pieces right here that it just separated? And what it's saying is, let me go ahead and put some, if when I draw this line, it separates this into proportional pieces. So like AD is proportional to, or excuse me, AD over DB is proportional to EC over EB. So separating these so that when I put them in ratios with each other, AD over DB and EC over EB, that they are proportional. We get the same scale factor. If this happens, then DE is parallel to AC. So this line that we've drawn in here is parallel to that one. That's also true going the other way. If these lines are parallel, then we know that it's going to separate this triangle into proportional pieces. So AD over DB is equal to EC over EB. We have seen that already. All right, so let's run down here and look at this. So let's see if DE is parallel to CB. So that's our question. Is DE parallel to CB? So yes or no here. All right, and the same question on this one. So if it is, then 6 over 4 has to be equal to 7.5 over 5. And by the way, we could go the other way with it. We could say 4 over 6 equals 5 over 7.5. Not just one way to set this one up. All right, so when I cross multiply, I should get the same number. So 3 times 5 should be equal to 7.5 times 2. And I reduced this. You do not have to do that. 15 equals $7.50, and $7.50 is 15 bucks. So another way you can do that, or just multiply it, totally fine. So those are equal. So yes, those lines are parallel to each other. All right, let's try this one. Is DE parallel to CB again? All right, so 5 over 2 has to be equal to 10 over, we don't have that piece. Can we find that piece? Well, we have this whole thing as 14, and this piece is 10, which forces that one to be 4. 10 over 4. Are those the same fractions? So if you can see, if I multiply 5 by 2, I get 10. Multiply 2 by 2, I get 4. So yes, they're the same. Or you can reduce this side, and yes, they're the same. Cross multiplying, we would get 20 for both, so you could check it that way as well. So yes on that. All right. The next theorem, let me move this guy down. So Theorem 9-7 deals with mid-segments. And it says, if a segment joins the midpoints of two sides of a triangle, then it is parallel to the third side, and its measure is half of the side that it's parallel to. So let's look at that. Let me just go ahead and get a triangle drawn here, and you can draw one as well. All right, so a mid-segment is going to come from finding the midpoint or the median of both sides and then connecting those two midpoints together. All right, so here's what the theorem says. If a segment joins the midpoints of two sides, which mine did, so we'll call this D and E. So let's put some marks here. Midpoint would mean that AD and DB are equal to each other, and BE and EC are equal to each other. All right. Then it is parallel to the third side. So DE now is parallel to AC, and DE is half of AC. Meaning, if I tell you that AC is 40, you know that DE is 20. Half of the side that it's parallel to. DE is parallel to AC, so it's half of that opposite side. All right. So I'm going to write it out in words over here. If a segment joins the midpoints of two sides of a triangle, then it's parallel to the third side, and it's half of the measure of the third side. All right, so DE is parallel to AC and it's half its measure. That also means if they tell you how long DE is, like let's say that they say DE is 15, we know AC is twice its size, that it is 30. All right, let's check out this next question. D, E, F are midpoints of the sides of ABC. So these are midpoints. So that means I know that that's congruent to that, that's congruent to that, that's congruent to that. I also know this side is parallel to this side. This side, oh man, different color. Come on, pick up the color. Here we go. This side is parallel to, okay. Are you kidding me? Let's try this again. All right, let me get this side. So the greens are parallel to each other. The blues are parallel to each other. And the purples are parallel to each other. All right, now we're ready. Okay, so AB, so AB green is parallel to DF. All right, if AC, there's AC, is 22, how long is EF? If you need to pause the video to do that one real quick, go right ahead. That's AC is 22. EF, which is a mid-segment, is half of that, so it would be 11. All right, AE is 6. What's the perimeter of DEF? The perimeter of DEF. All right, so if AE is 6, then we know this whole thing is 12, which tells me that this guy right here is 6. True? So now we should be able to find the perimeter of DEF. Can we do that? Absolutely. All right. So you guys go ahead and do that, and you can show that to me when you come to class. And then you can also do this next one, CF. Oh, by the way, do you see these little, I'll give you a hint on that one. Do you see these little angle markings that these angles are all congruent, which tells me my sides are all congruent, which tells me something about these sides and about these sides. All right. CF is 9. Find the perimeter of ABC. If CF is 9 and this is a mid-segment, we should know how long this side is too, right? So I have 18 here. I want to see your answer for number 10 as well. So I have 18 for this side. What do we know about all the sides of the triangle? All right, guys. Good job, and I will see you soon. This is Coach Lowe, and I'm out.